Stanford University.
Okay, well, welcome then to lecture number 5 of CS193P. And today is going to be about half lecture and half demo. And a lot of the stuff in the demo is going to be covered in the lecture. So I'm going to try and balance between going into great detail in the slides on some of the items versus just showing you in the demo in great detail. So some of the things you'll see slides come up and I'll talk about them, and I'm only going to be really briefly covering it. And then in the demo I'll go into a lot more detail, and vice versa. Some things I'll be covering in the slides a little more, and then we won't be covering, although we'll cover almost everything in the demo today. So before we start, a couple of things. One question that's come up evidently in office hours quite a bit is people are somewhat disturbed that we made description of program and run program be class methods, that we give out this cookie, which is an instance of the program, and then we go back to the calculator brain later and ask a class method to do it. And so the question, I guess, is what's the rationale behind doing it that way? And I suppose those people who are asking that would prefer that we give out the program and then somehow you send messages to that instance of the program. Okay, that it not be an opaque class, not be an ID, but instead be some known class that you can send messages to, like run or something like that. And that certainly would have been one way to do it. I think I even mentioned when I was doing the demo, we could have a calculator program class and make that public, and you could send run to it and all those kinds of things. But two reasons that we did it this way. One is I want you to have experience with using ID as an opaque class, and this is an example of where you would give something out, a cookie. It's an opaque class. The users of the program don't know what kind of class it is, and that's perfectly fine because you're providing utility methods to let them do operations on it anyway. And also I want you to learn about class methods. So you got run program, description program, you got to implement some class method. You get to see what that's like and what the limitations there are and what the benefits there are. From a pure design sense, it's not necessarily a bad thing in that someone might get that program and want to use it much later. You know, sometime in the future when they don't even have that calculator brain anymore. It's gone. And they don't want to create an instance of a calculator brain either. All they want is to run that program. Okay? And for them, you shouldn't necessarily force them to go back and create an instance or whatever, right? And in fact, you're going to see that with this week's homework, right? We're going to turn our calculator into a graphing calculator. And the thing that does the graphing, it doesn't need a calculator brain and all. It's not pushing operands or variables or anything like that. It just wants to get a program and graph it, okay? So it's really nice for it that it's got this cookie thing, program, and it can just call these class utility methods to run it and get the values that it wants, including the description of it. So that's the rationale behind that. Hopefully that's understandable. So it's both pedagogical, trying to teach you about those new concepts, and also it has good kind of just design sense behind it as well. All right. A couple more things I want to cover too about last Thursday's demo, and I think I still have this up in Xcode. Let's take a quick look. Yeah, here it is. So 2 lines of code that I wrote in this demo on Thursday I want to look at real quickly. This one right here. So the property, you notice this @ program or @ property read-only ID program doesn't specify strong or weak. Okay, does everyone understand why it doesn't specify strong or weak? Okay, it is a pointer into the heap, but it's not actually setting a pointer into the heap. It's just returning it to you. It's read-only. So whoever calls this is going to put it, presumably, into some variable, either a local variable or maybe some instance variable, and that is going to be strong or weak. Remember that all local variables are strong, but they only last for the scope of that method. And then any property you would want to put this in to keep it, it's going to be strong or weak. So that's when you got to specify the strong or weak, right? So this is the fact that this is read-only. If this weren't read-only, we would have to specify whether it's strongly or weakly holding whatever it's going to point to in the heap. And the other method was over here. This is in perform operation. Inside perform operation, which is an instance method in calculator brain, we call a class method. Okay, run program. Now we call run program, and in your one you're going to have run program using variable values also, but you don't know the variable values here, so you just pass nil probably for that. But the key here is this: how we call the class method. So we call the class method by using calculator brain. But there's another way we could have done this, which is we could have said self-class. Okay? Remember that there is an instance method from NSObject that all objects inherit called class, and it returns the class of this instance. Now, why would this be different? Anyone know why this would be different than when we had it before? Begins with an I. Inheritance, exactly. Okay, if we do it this way, then we get inheritance on run program. If someone subclassed calculator brain and overrode run program, this line of code would call their version. Whereas if we had it the old way, which was just calculator brain, even if someone subclassed the calculator brain, this line of code would call calculator brain's version of it. Make sense? Minor difference, but I thought I'd share that with you. Okay. What are we going to do today? Today we're going to talk about auto rotation, which is you have your device and you turn it and your bounds of your views change, right? Because if you had something in portrait and you turn it to landscape, your bounds went from being tall and not so wide to wide and not so tall. Okay? So how do we deal with auto rotation? We're going to talk about today. We're also going to talk about another Objective-C language feature, which is protocols, a really important one. And last Thursday I talked in custom UI views how you do drawing by implementing your DrawRect. Now I'm going to talk about how you handle touch events by adding gesture recognizers to your view. And then finally I'm going to do a demo. It's going to demo everything we saw at the second half of Thursday, all that stuff about drawing and views, and it's going to demo pretty much everything I'm going to talk about today. That demo might run over a little bit. We'll just finish it on Thursday and then dive into the next thing after that. All right, so auto rotation. What goes on in your controller when the device is rotated? Well, one thing that happens is that your controller's views are all going to have their frames modified, but only if your controller wants it to. So your controller can implement this method, should auto rotate to interface orientation, and return whether your controller wants to allow its view to rotate, auto rotate when the device rotates, to the given orientation. Now, this orientation, UI interface orientation, is either UI interface orientation portrait, UI user interface orientation portrait upside down, landscape left, or landscape right, okay, which is landscape with the home button on the left, landscape with the home button on the right. Those are the four orientations you can go into. And so you could either, there's a macro called UI interface orientation is portrait, so you could pass the portrait to that macro and find out if it's one of the two portrait ones. You could also just return yes, which means I'll rotate to any orientation. I'll allow my views to be rearranged to any orientation. And, or you could just prohibit one particular one, like maybe you just don't like the upside down because you don't want the home button on the top. But you'll allow landscape and you'll allow normal portrait, okay? So you just implement this method in your controller, your view controller. And so for whatever orientations you support, when you get to that, your view is going to change its bounds, right? Bounds are going to be changed, again, to be wide and thin versus tall, wide and short versus tall and thin or something like that. And all the subviews are also going to have their frames changed, and all their subviews are going to have their frames changed. Now, the question is, what are the rules for all these changes? And the rules are determined by these things called struts and springs. And I'm going to show you how you set those in Xcode. One thing to notice, and we're going to talk about this in a couple of slides, is when the view's bounds changes in this way, okay, gets moved around, the struts and springs decide where it's going to be put, your DrawRect does not by default get called again. Okay, and we'll talk about what happens, how your view gets redisplayed once it's changed its size. But your DrawRect by default does not get called. We'll talk about that. So, struts and springs. Here's how you set them. You set them with the size inspector in Xcode. This is like in the upper right-hand corner. If you have the right-hand utilities area showing, this in the upper right-hand corner, so you can see the little icons on the top for identity inspector, attributes inspector. So we have the size inspector selected here. And at the top of this, you can see there's the size. Okay? And then at the bottom, there's this thing that lets you set the struts and springs. Now, the struts and springs are the little red things in the lower left. The I-beams, the things that look like eyes, those are struts. And the arrows in the middle, those are springs. Okay? They don't look like springs, but that's what we call them. And you can turn those things on and off just by clicking on them. They toggle. You click on one, it'll turn off. You click, it'll turn right back on. And on the right, there's a little window right there that kind of looks like a screen of a computer. And it will animate to show you what this view is going to do with respect to its super view when things change. So the outer white box in the preview is the super view, and the red box is this view that you're editing. Right? You've got some view selected, and you're editing it here in the size inspector. Okay? So what would this springs and struts do? This one, the springs are in both directions in the middle. There's only two springs, vertical and horizontal. They're both on. So when the super view changes size, our view that's being inspected here, it'll also change size in both directions. All four struts are also on. So that means it's going to keep the same distance to the edges of its super view. So in other words, as the super view gets bigger and smaller, our view is going to get bigger and smaller. Understand this setting? So here's another example. This one, only the horizontal spring is on, but I have the top strut and the left and right strut. So my view in this case is going to stick to the top, okay, and it's going to get wider and stick to both edges. But the bottom, it's going to be free floating off the bottom. So if my view got really tall because I was in landscape mode and I rotated to portrait, for example, or something else happened to make my super view really tall, I would stay at the top and a lot of space would be at the bottom. You see? Then here's another one. This one, my view will not resize, stay the exact same size no matter how big or small my super view gets, but I'll always stay in the upper left-hand corner at the same distance from the left and the top, because I got the struts in the left, but I don't have any springs in the middle. Everyone cool with this? So by setting your springs and struts, you can say what happens when the super view changes size. And this is surprisingly easy to set a lot of stuff to work nicely. Now on the Mac, there's quite a in the latest Mac Lion, there's quite a sophisticated mechanism for laying out views. Not so much needed on a phone. Okay, this is small, and you could also get involved in code if you had to. But when you have such a small space, it's usually you can manage a lot of things. But some things can't be done with strings and struts. For example, in your mind, imagine your calculator is in portrait mode, and you rotate to landscape. Could you really just with strings and struts make those buttons like realign and line up? Probably not. Okay? So that's a case where you'd probably have to have code involved. And there is a method that gets called in your controller, did rotate to user interface orientation, I think it's called, and there's another one, maybe will animate to user interface rotation. You can find out and then get involved and move the views around yourself. So you can do that. Not required for this class at all. Okay? Okay, so I told you that when your bounds changes, though, like the springs and struts cause your view to get wider. What happens to your custom view? Does it get its draw rect called again? And the answer, no, it doesn't. For performance reason, the bits of your view get stretched or squished. So you're going to get a grainy kind of thing if you are drawing something high resolution. Luckily, there's a way to control this in your controller, or sorry, in your view, not in your controller, in your view, in your custom view. There's a property called the content mode that describes what your view does when its bounds get changed because someone said its frame, right? And there's really three kinds here. There's the first one, which is the content mode left, content mode right, content mode top. That should be bottom, not right again. Bottom left, etc. All the positional ones. What they do is they take your view, the bits of it, and move it to that location. Okay? Now this is not strings and struts I'm talking about. That's already happened, let's say. Here we're just talking about my view got wider. What do I do with the bits of my view before it got wider? Well, if it was UI content mode right, all those bits would get moved over to the right. Okay? The second mode is scale. Scale to fill, scale aspect fill, and scale aspect fit. That's going to stretch out the pixels of your bits of your view. Okay? And we'll see this in the demo. So when you see it, you'll believe it. And in fact, that's the default. Scale to fill is the default, where it will scale the pixels in both directions to fill the new space, bigger or smaller, which could really distort. It doesn't keep the aspect ratio. It could really distort your thing. So often this is not what you want. The third one is the one a lot of times you do want, which is redraw. And that just basically means call my draw rect again. All right? And that's the most sensible one that you can imagine. It's not high performance, of course, but you know, it's pretty high performance. And the default is scale fill. And there's another property called content stretch, which is really cool. I'm not going to really talk about it in detail. But you can actually specify a sub-rectangle of your view's bits to get stretched. So if you had some kind of frame that was, you know, that got stretched, it would look funny, but the middle is just open space, like your UI button, for example, a rounded rect button. The middle of the rounded rect button could get stretched and look fine because there's no pixels in there, basically, but the edge you wouldn't want to. So content stretch lets you specify a rectangle inside your view that you can stretch. Again, you're not going to have to do that in this class. Okay, another topic, initializing a UI view. Now, if you wanted to set up some initial state of your custom view, right, you're writing a custom view like we talked about on Thursday, and it's got its own draw rect, but it needs some state set up, like it wants to set the content mode, for example. Of course, you would override init with frame. That's the designated initializer, and you do that self equals super init with frame business. But the problem with that is when your view comes out of a storyboard, its init with frame is not called. Okay, and most of the UI views you're going to build in this class are coming out of a storyboard. Okay, so how do we deal with that fact? Well, the answer is that there's a method called awake from nib. It's called that for historical reasons. That is called when a view comes out of a storyboard. And so any setup code that you would want, you're going to call from both init with frame, so that if someone does alloc init with frame on your custom view, it works. And you're also going to do it in awake from nib, just in case your view is coming out of a storyboard. And you'll see what it means for a view to come out of a storyboard in the demo today. So this is the kind of code you would have, right? You'd have some shared setup method, and you'd call it from awake from nib, and you'd call it from your init with frame. Okay, any questions about that? Very simple, straightforward, yeah?
Is there any difference between calling it in like a later thing, like view did load, between calling it in...
Yeah, the question is, can we call this stuff later in view did load? And we haven't talked about view did load in the life cycle, and we'll talk about that on Thursday. But yeah, absolutely. I recommend against putting stuff in your init with frame if you can. Put it somewhere else. Put it in a setter for a property, for example, is a good place to put things sometimes. And we'll do that in the demo as well. So yeah, if there's another place to put it, by all means. Don't feel like you have to override init with frame and awake from nib. All right, protocols. A new Objective-C thing. The syntax of protocols looks very much like the syntax for @sign interface. A couple of things to think about. One is that, of course, a protocol, there's no corresponding @sign implementation, right? The implementation of a protocol happens in other objects. So all a protocol is a collection of methods and or properties that you're going to ask some other object to implement. Very simple. The only syntactical thing, one is that you can actually have your protocol depend on other protocols. In other words, in this case right here, if someone wants to implement the protocol foo, if some object says, I'm going to implement the protocol foo, they must also implement the protocol other and the protocol ns object. Okay, those are two other protocols. The protocol NSObject, by the way, basically includes all the methods in NSObject. So if you have a protocol and you put this angle bracket thing after it to say, if you implement this protocol, you got to implement NSObject too, you're basically saying that foo is a protocol that an object has to implement, an NSObject has to implement it, right? So you can do things like introspection on that object and stuff like that. So we often do that. I think in Xcode, if you start typing @sign protocol, it's going to automatically put angle bracket NSObject after it. Since all objects are pretty much NSObjects anyway in iOS, that's really not a problem. It's kind of a good thing. So anyway, then you just start listing the methods. You can kind of, all the methods are required unless you turn on this optional flag. You see how this after the first one, I put @sign optional. That means now all the methods that I'm listing are all optional. Until I do @sign required, now they're starting to be required again. So in this protocol, do something and get many somethings and the property foo prop are all required. But the two in the middle, get something and do something optional with argument, those are optional, not required. In other words, you can implement, you can say you implement this protocol and not implement those methods, and that's allowed. Question?
Besides NS objects, what can implement a protocol? Isn't everything an NS object?
So the question is, besides?
What is there besides NS objects that could technically implement a protocol? Isn't every object?
Oh, so the question is, what besides an NS object could implement a protocol? And the answer is, any object could. Now, the reality is, we always inherit from NS object. That's just something we do, but we don't have to. There's no law that says we have to, but we are going to. We always do. So yeah, so it's one of those things where we always do it. But protocols have nothing to do with NS object. You know.
Are there any other objects in iOS that come that don't inherit from NS object?
The question is, are there any objects in iOS that don't inherit from NS object? And the answer is, I'm not aware of any. Okay, so yeah, so we talked about the required. Protocols are defined, or declared, I should say, you know, it's kind of declared, in header files. And they could be in their own header file. I could have a header file called foo.h, which just has this protocol declared in it. And it's imported into classes that both want to implement this protocol and also want to use the protocol. In other words, want to send messages to objects that implement the protocol. But a lot of times, there's only one object that actually wants to talk to objects that implement a protocol, and so you'll put this protocol in its header file. So for example, scroll view, which is an iOS class we haven't really talked about, but you can imagine what it does. It has a delegate that has like a dozen methods that it can send to its delegate, and it defines those in a protocol that's defined in scrollview.h. Okay, so you can put a protocol in another class's header file at the top or at the bottom, wherever. And you can also put it in its own. It totally doesn't matter. So you got a protocol declared somewhere. Classes then say that they implement a protocol by using the angle bracket notation on the end of their @ interface. So this class, my class, inherits from NS object, and it implements the protocol foo. Okay? So I'm declaring that I implement the protocol foo. Well, now I have to implement all the non-optional methods in foo, and if I don't, the compiler will complain. Okay, the compiler will say incomplete implementation if you don't implement all the required methods in the foo protocol. Now we've got declared protocols. We've got objects that are saying that they'll implement a protocol. Now we can have a new type, which is ID angle bracket protocol, that says this is a pointer to an object of unknown class. That's what ID is, that implements this protocol. So I can send messages to these objects of this type that are in the foo protocol, and I don't have to do introspection or anything. I know that those things implement this, and the compiler will check that for me at compile time. So, for example, if I say ID angle bracket foo obj equals my class alloc init, that's a winner, because look at my class up above. It implements foo. So the compiler's like, yeah, okay, that's good. But if I say ID foo obj equals NS array, that's bad, because NS array does not implement the foo protocol, and so the compiler will complain in this case. And not only can we declare variables, we can also pass them as arguments. So I could have a method here, give me foo object, and its argument is an object implementing foo. The type of that argument is ID foo. In other words, an object of unknown class that responds to these foo methods. Okay? The required ones anyway. And we can also have properties of this type. So I could have property, my foo property, which is ID implements foo. Everyone cool with the properties, with the protocols? Pretty straightforward, actually. Pretty simple syntax. Okay, just like static typing, all this stuff is just sugar for the compiler to help you find bugs. At runtime, it doesn't matter. At runtime, the runtime is going to look at the object and see if it actually implements that method. And if it does, it's going to send the message. And if it's not, it's going to raise an exception. No matter what you did in terms of protocols or static typing or anything in your code, this is all just compiler helping you find problems kind of thing. You can think of it as documentation for messages you allow to be sent to these objects of type ID. Right? It's great documentation because you know this is an object of unknown type. I don't know what kind of class it is, but I know it implements this method. So that's good documentation of that. Okay, the number one use of protocols in iOS is delegates and data sources. If you remember back to the first lecture, the very first lecture in this class. I drew the MVC things, and I talked about how, for example, a view never wants to know the class of its controller. Because views, these minions of the controller, are generic. They're things like UI button. Obviously, the internal code of UI button can't know anything about a calculator view controller. So it has to be able to talk to a calculator view controller generically. And we know that one way it does that is with target action. And another way it can do it is through delegation. Okay, so delegation, important part of this class. Now, data source, when we use the phrase data source, we're still talking about delegation, but we're talking about specifically delegating the source of data for a view, because remember, views cannot own their data. Views cannot have a property, an instance variable-based property, that points to their data that they're drawing. They can have properties for things like how they draw, maybe the color they're using or something like that, but they should not have a pointer to the data that they're actually presenting. That's the purview of the controller, because only the controller can talk to the model, who is usually providing the information that a view is displaying. Okay? So here's a typical declaration of a delegate. At-sign property, non-atomic, weak. We almost always have delegates be weak, because the object that is being set as the delegate usually is the owner or the creator of the object that is using the delegate. For example, in the view case, we know that the views are the minions of the controller. So if the controller sets itself as the delegate or data source of a view, which it often does, very, very often does, you don't want a strong pointer back so that they're both pointing to each other strongly, right? Because now you got stuff in the heap that's pointing to itself strongly. It's harder to unhook that so that they both can get freed at some point. Right? So the view only points weakly back to the controller. If the controller were to go away, the view can't do anything anyway. It's the controller's minion. So if the controller is gone, then the view is useless. So it's fine for its back pointer to get set to nil. So here's an example. This is scroll views. So here is, for example, scroll view.h. A little bit simplified, so it fits on this slide. And you can see that scrollview.h declares this UI scrollview delegate protocol. All of the methods happen to be optional, so it starts out with optional and then lists all the methods. I haven't shown them all, just a couple of them. There's over a dozen. And then here comes the actual interface of UI scrollview. We're in scrollview.h, so we need that. And you notice that there's a whole bunch of stuff there, but all taken out except for one thing, which is this property, which is weak. Right, which is an ID that responds to the UI scrollview delegate protocol. It's called delegate. That's the name of the property. Now you might say, why does it even waste its time doing all this protocol stuff when they're all optional anyway? Again, it's a documentation thing. When you set yourself as the delegate of a scroll view, you can go look at this protocol, UI scrollview delegate, and see what the methods in there that you can implement are. So it's documentation. And then let's say we have a class that wants to use a scroll view in this way. I'm going to call it myViewController. Notice that myViewController declares that it implements the UI scrollview delegate protocol, right, in its @sign interface. You see that very first line there. And it has, let's say, an outlet that points to a scroll view in its view somewhere. And it wants to be the delegate of that scroll view, so that when things happen in that scroll view, it gets delegate messages. So, for example, in the setter for that outlet, the scroll view outlet, it does underbar scroll view equals scroll view, which is what setters do. And then it says self.scrollview.delegate equals self. It sets itself to be that scroll view's delegate. And now, methods like this one here, view for zooming in scroll view, which is a scroll view delegate method, will be sent to myViewController because it set itself as the delegate. Everybody got that? Now, this is, a little bit of object setting pointers, and then pointers being used to send messages back to objects and stuff like that. So it can be a little confusing at start. When I do the demo today, I'll try to, reiterate every time, okay, I'm setting this pointer so that I'll get this message back. But there's really no substitute for doing it, which is why you're going to have to do this in your next assignment. Okay, that's it for protocols. No questions? Okay. Next, we're going to talk about gesture recognizers. Okay? So there's really two ways that you could get touch input from the screen into your custom view. Right? So someone touches on your custom view. You got a draw rect. You draw something in there. And someone's touching on it, and you can get that information. How can you get it? Well, you can get the raw touch information, like a one finger went down here and it moved a little over here, then another finger went over here and they both moved down. And you can get all that information at a very low level. But man, if you were trying to implement pinching, imagine what your code would look like. Okay, trying to keep track of those two fingers. Oh, what if a third finger goes down? Now what do I do? What if one of the fingers goes up and comes back down? I mean, it's really, that would be complicated. So, and you used to have to do it that way, but nowadays we use gesture recognizers instead. So in this class, you will never have to do that raw touch management. Okay, we're going to use gesture recognizers for all of our touch input. So how does gesture recognizer work? Basically, a gesture recognizer is an object that you attach to a view, and it watches the touch events that happen in that view. And when it recognizes a pattern of touches that matches the kind of gesture it is, like a pinch or a swipe or a pan or something like that, or tap, then it sends messages to its handler, the gesture recognizer's handler, we'll talk about that, saying, oh, this gesture is happening, and then you can respond to it. It's as simple as that, okay? And it does all the work of dealing with some gestures kind of interfere with each other, and the difference between a two-finger scroll and maybe a start of a pinch, it deals with all that for you. It's really awesome. The base class is UI Gesture Recognizer. That's abstract. So you never actually create an instance of UI Gesture Recognizer. There's a whole bunch of concrete subclasses of it that, like pinch gesture recognizer, pan gesture recognizer, and those are the things that you create and attach to a view. So there's two sides to getting gesture recognizer to work. There's creating one and attaching it to a view, and then there's handling it when it gets recognized, when it actually happens. Okay? Now, the first one of those is usually done by a controller. Okay? The controller is usually the one who decides, since its views are its minions, it's the one who decides, okay, I'm going to have this view implement pan and pinch. Okay? Pan and pinch mean something in this view. I'm going to turn that on, essentially. However, the handling of it, the actual what to do when a pinch happens, a lot of times that will be done by the view. Okay? Because, if I'm a custom view, I know how to pinch on myself. Or swipe, or double tap. I know how to do that stuff. I own my internal state. I know how to do that a lot better sometimes than my controller does. But we're still going to let the controller add the gesture recognizer to the view, kind of to turn it on. Now, other handlers for some gestures might be implemented by the controller. Specifically, gestures that are modifying the model. Right? If you have a gesture that does something that changes the model, the controller wants to handle that because the view can't see the model. Do you see why that is? So bottom line is controllers usually add gestures. It is possible for a view to add a gesture to itself. If there's some view that just makes no sense if this gesture is not recognized, it could conceivably add it itself. That does happen. Scroll view, for example, it adds gestures itself for panning and zooming. Okay, scroll view, that's what it does. So it wouldn't make any sense for it not to do that. However, a controller could remove those gestures. If it wanted a scroll view that wouldn't pan, it could remove those gestures, but generally not. But then the handlers can be implemented really by anybody, but often it's either the controller or the view, and we'll see. In the demo today, we'll do one of each. All right, so this is what the code looks like to add a gesture recognizer to a view. Okay, remember, like I say, you create a gesture recognizer, you add it to a view. A view has got a list of them. Okay, a bunch of gestures that it recognizes. And yeah, they might conflict, and the system deals with that, possible conflicts. So here, this is, for example, the setter of some outlet. Okay, I'm in my controller here, so this is code in a controller. It's got an outlet to some pannable view, some view that can be pannable. And so first it does the underbar pannable equals whatever. And so now I'm creating a pan gesture recognizer. It's a concrete subclass of UI gesture recognizer. It's called UI pan gesture recognizer. And there's other concrete classes, but in this case I'm creating a pan. And the initializer for any gesture recognizer actually is init with target : action : So it's kind of like target action in a way. Not exactly the same, but kind of like that. So the target is who, meaning what object, is going to handle when this gesture gets recognized. So in this case, I'm going to ask the view to handle it, the view itself. The same view I'm adding this gesture recognizer to, it's also going to handle it. And then pan : is the method that's going to be sent to the view. Okay, the action is going to be sent to the target when this gesture starts to be recognized and continues to be recognized. The argument to pan colon is not sender, though. It's the gesture recognizer. It's basically the gesture recognizer that caused this message to be sent. So it's kind of the sender, if you want to think of it that way. It's the gesture recognizer is the sender. So that way you can ask back to the gesture recognizer information so you can make your decision, and we'll see that. And then I just call this method in UI view called add gesture recognizer, and boom, it's done. So now that view is going to start recognizing pans, and when a pan happens, it's going to send pan colon to the target, which is the view itself. Okay? Everyone cool with that? Question?
It will always pass itself as a parameter?
Will it always pass itself as a parameter?
Gesture recognizer always pass itself.
Yes. You can actually not put the colon on there, and then it will pass no arguments. And like a tap might be okay. You don't need any information. The tap happens or not. But usually you have a pan colon, and the argument is the gesture recognizer itself. Yeah. Okay. So how do we implement the target of a gesture recognizer? How do we implement that pan colon thing? What does that look like? Well, the concrete classes provide methods. Each concrete class provides its own methods that have to do with what it's doing. So, for example, pan. Pan gesture provides these three methods. Okay? The first method is translation in view, which will give you a point that tells you the distance of the pan from the last point that was set in the gesture. Okay? And it starts out with the first, wherever the touch first went down, that's the start. And as it moves, it'll tell you the distance from that point, but it's also possible to reset that start point. And then it'll be kind of tell you incremental distance as it moves around. Okay? Velocity in view tells you how fast that finger's moving. That's instantaneous velocity, right? And it's like that's in points moved per second. And then you can also set translation in view. So that's the opposite. That's like setting the thing the first thing is getting. And that's what you would set back to 0 if you just wanted to keep getting incremental updates. Right? You set that translation back to 0, and the next time you're going to get the difference between 0 and that. So you're going to get these incremental updates to the position. And that's a common mechanism when you're doing the gesture recognizer, is to reset the thing it's reporting you back to 0, or if it's like a scale for a pinch, you reset it back to 1, and then you're going to be getting constantly incremental updates. You'll see that in the demo. It'll make a lot more sense. And then in addition to the concrete classes having methods that are appropriate to their concrete class, there's a very important property in the base class UI gesture recognizer called state. Okay, so this is a state machine. This whole gesture recognizing mechanism is a state machine. All recognizers start out in this state possible. So this gesture is possible. And then when if a gesture is discrete, like it's a tap, then you'll get the state changing to recognized. Right? So your handle will get called and the state will be recognized. That's if it's discrete. If it's continuous, like a pan or a pinch, then you're going to get began when it starts. You're going to get changed as the position changes or the thing changes, and then end when the finger lifts off, okay? Or like in a pinch, one of the fingers goes off. So that's kind of the state machine. There is failed and canceled. You only really have to watch for failed and canceled if you implement your state machine as a stateful operation. In other words, the began starts and you set some state in yourself, and then you're tracking that state, and then you undo the state when it ends. Okay? Now, normally we don't implement our gestures that way. We try to implement them statelessly. So something happens, we pinch a little bit, we modify our view in some way, react to the pinch, and then we're back into the same state we were before. If the pinch continues to move, we modify ourselves again, and we're back into a state we were before. We don't tend to try and keep state around. It makes it a lot easier to implement our gesture recognizer. So you only have to deal with failed or canceled if you keep that state around, because you've got to clean up that state. Okay? And failed and canceled can happen in states where you are doing a certain gesture and some other gesture interferes. Okay, like you're doing a pinch and it turns into a three-finger tap or something. I don't know, something that would interfere. Or you're doing a gesture and the phone call comes in and you're gone. Okay, that would obviously cancel the gesture. All right, so given this information, what would pan look like, for example? So the argument, as you can see, is the pan gesture recognizer. I'm going to do a stateless pan. So I only am interested in the changed and ended. I only want to know when that pan is moving. Okay? All right? Anytime it moves, I'm going to do something. I'm going to get the translation. That's how far the pan moved from the last time it was reset, or from the beginning, by saying translation in view. This code, remember, is in my view. I decided to implement pan in my view. So self is my view. Now I've got the translation, so I'm going to move something, like maybe I might have a property on myself, which is my origin. I'm going to move that origin by the translation or something. I'll do whatever I want to do now that I know how much the pan has moved. And then I'm going to reset the translation back to 0. And that's because the next time this handler is called, I want the amount that the pan has moved. I don't want the total amount the pan from the start. I just want the amount it moved. Because every time it moves, I reset my origin. So I'm in a stateless case where all the time when new information comes in, I can just move from there. All right? Okay. Other concrete gestures that are available. There's pinch. Pinch's main methods are scale, which is a float that tells you the scale. So when the pinch first starts, the scale is 1. As it moves out, the scale will be at 1.07, 1.1. If it moves in, 0.9, 0.8. And again, scale is writable, so you can always reset the scale back to 1, and then every time it moves, you'll be getting relative to the last scale. Okay, so incremental as opposed to combined. And then velocity, same thing here. It's the velocity that's moving, and that's moving in scale factor per second, how fast the scale is happening. Rotation gesture is 2 fingers down, turn, right? That's kind of a cool gesture. That's angular velocity. The velocity is angular velocity in radians. And the rotation, yeah, it's in radians, right? So to make sure you realize it's in radians, not degrees or something. And you can reset that also. Swipe gesture, it recognizes different kinds of swipes. 2-finger swipe, horizontal, vertical, 3-finger, 1-finger, etc. So the way you do this is you create a concrete swipe gesture recognizer, and then you set some properties in it for how many fingers, what direction, etc. And then you'll get recognized when the handler gets called. Question?
Often when you rotate things, it scales at the same time, so will only one gesture recognizer get called?
Okay, so the question is, what if I am doing 2-finger rotation and, oh, my fingers come apart a little bit? And am I going to get scale too? Well, it totally depends on whether you add both a rotation gesture recognizer and a pinch one.
They won't cancel each other.
They won't cancel each other. They'll work together. Yeah. And then tap gesture, similar to swipe. You say how many taps, how many fingers, all that business, and it will send you recognized when it recognizes it. All right. So demo time. Got a half hour for this demo. It's a long demo because I'm going to cover a lot of stuff here. But the most important thing to understand about this, I'm going to build a new application. Okay, this is no longer a calculator. New application. This application, let's understand its MVC. Okay, it has a very simple model, which is an int. Okay, I decided to make it simple so that we would not have to spend a lot of time on it. Okay, it's an int. It's the happiness. So what our application is going to do is it's going to show us our happiness and let us say how happy we are with the gesture. Okay, that's what this thing does. And our happiness is stored as it's the model, and it's stored in the controller as an int. And 0 means very, very sad, and 100 means very, very happy. Okay, so that's our model. The view is going to be basically one view in our controller's view, which is a custom view that I'm going to write called face view. And it's going to draw a face, and the face is going to be smiling if it's happy and sad if it's not. Okay? Now, we're going to do all the work to create the face and the face view, and we'll add a gesture to it that does something at the beginning, and at the very end, then we're actually going to hook our face up to our controller. So don't be disturbed by the fact that a lot of the stuff we do early on is not, the face is not showing our happiness in the controller. We're going to do that at the end, okay, using delegation and all that business. So what to watch for here? Tons of things to watch for. We're going to do our own draw rect. We're going to have a little subroutine in our draw rect. Definitely want to watch how we do the delegation, which we may or may not get to today. That might be the first thing we do on Thursday. And also notice we're going to have 2 gestures. One that's going to be handled by the view because it's only modifying the way the view is displayed, and another one that's handled by the controller because it's going to modify our model. Okay, it's going to actually change our happiness. Okay, so that's it. get started here. Let's go start a new project here. Okay, so again, new project. So I'm just going to create new project. You're used to this. It's going to be a single view MVC. I'm going to call it happiness. Class prefix, I'm going to use happiness. It's going to be an iPhone project for now, although on Thursday we're going to switch this to be universal. So you can look forward to that. We're going to store it in our home directory developer as usual. I'm not going to do source control on this one. All right, so here's our storyboard. Okay, we'll hide some stuff here to make some space. Our storyboard is blank. Okay, we have nothing in there. And here's our controller. As usual, I'm going to clean out this stuff, not because we don't want some of it, we do actually, but I want it to be as clear as possible what's going on step by step. So I'll add it back. I'll add back the stuff that we want to add back. All right, so the first thing I'm going to do in this thing is I'm going to create my model, view, and controller. Sometimes when you're building a new app, it's good to just put a skeleton model, view, and controller in there so you don't get confused about what your model is, what's in your view, etc. So the model we can do first, very simple. I'm just going to make it be a property, non-atomic, int, happiness. It's public. I'm going to allow people to set my model, and that's perfectly fine too. People, you know, there's no law that says an MVC's model has to be read-only. Okay, quite the opposite. In fact, a lot of times what a controller does is allow you to input data into the model. So here we're going to make that a public method. But since it's public, I'm actually going to put a comment in here. And somebody asked me about comments. Like, I notice you don't ever comment your code in the demos. Well, it's because I'm racing against time to show you as much as possible. And also, I'm commenting it verbally as we go, right? Massive amounts of it. But here I am going to put it, and I'm going to say 0 is sad, 100, oops, is very happy. And I'm just making this up. So the main thing I want is I want the model's idea of happiness to be different than our face views so that I can show you the controllers, their job is to translate between the model's idea of something and the views. So obviously we got a warning there because we have to assign synthesize this thing. Happiness equals underbar happiness. Let's go ahead and create our view. I'm not going to do the draw rect right off the bat, but let's just create it. The way we create a new custom view with our own draw rect is the same way we create any new class. We go to New File. Now, when we get to New File, be careful. You might get confused and go down here. You see where it says User Interface? And you're going to see View, and you're like, oh, yeah, that's why I want to create a view. But that actually creates a view, a kind of a standalone view outside of a storyboard. We don't really want to do that. You want to be up here in Cocoa Touch and just say create Objective-C class. And when you create Objective-C class here, it's going to say what subclass you want, and you can pick view. Right? You can pick NSObject, like we did for Calculator Brain, or UI view. So I'm going to call it face view, because that's what it's going to do. It's going to draw a face. I'm going to make sure I put it in the right place, which is where all my other files are, basically. And so here it is. And you can see it's even stubbed out this init with frame, although it didn't stub out the awake from nib. So if we go put something in here, we're going to want to make sure we put it in awake from nib also. And then here's our draw rect. You can see that it's commented out. It's not just stubbed out, it's commented out. And you can read the comment there. There's a little bit of a performance reason for that. So now that we have our face view, let's go back to our controller and create an outlet to it. And then we'll go to our storyboard and actually drag one out. Okay? So I'm going to make that be private. So I'm going to say @interface happiness view controller parentheses. You'll remember that's how we make private things. And I'm going to say property non-atomic weak IB outlet. This is how we make outlets, right? Face view star face view. And I got a little error here. That's because I have to import face view. .h. And I better synthesize it. Okay, and I'm going to do one other interesting thing here too, which is I'm going to hook it up so that every time my model changes, I'm going to redraw my view. Okay, and I'm going to do that by saying void set happiness, which is my setter for my happiness thing, happiness model. And say happiness equals happiness, which is what we do in setters. And then I'm just going to say self.faceView set needs display. Okay, now you remember, we don't never call draw rect directly. We just say set needs display. So now anytime our happiness gets set, we're going to redraw our view, because we know that our view is reflecting, somehow is going to, later in this demo, reflect our happiness. It better. And so let's go ahead and redraw it. So now let's go over to our storyboard and drag out a face view. So I'm going to go over here. Now when I go down to the object library here, I can find view controllers, labels, rounded rect buttons. You're familiar with all this text field. And of course, if I go down this list, I'm not going to find face view here because VS Code knows nothing about that. But I do find generic view. You see, represents a rectangular region in which it draws and receives events. That's what a view is. So I can actually pull this out, and I'm going to make this fill my entire view. So see, I'm using the blue guides here to fill the entire view. And for example, if I go over to my size inspector, my struts and springs, right now you see the animation. It's showing that if my super view changes its size in any way, I'm going to stick to its edges, which is exactly what I want here. You know, if I turned off this, for example, then it might stay at the top, which I wouldn't want. Okay, so I'll turn these back on and make sure that's good. And then the other really important thing to do not forget to do this in your assignment, when you drag out a generic UI view, you need to change its class using the identity inspector. Okay, the identity inspector, see where it says show the identity inspector. The very first thing in the identity inspector is the class of the thing that's selected. And so we're just going to go here, down to face view. Click that. Now this is a face view. All right. The only other thing we need to do is wire up our outlet. Our controller has an outlet that hooks up to our face view. We could do that by, for example, bringing up the assistant editor right here, going over here, and using control drag to hook this up. Right? That would definitely be one way to do it, probably be the way we would do it. But I'm going to show you another quick way to do it, which is that this little icon down here, that represents your controller. I explained that in the walkthrough. Hopefully you got that. So I can actually control drag from here, okay, if I want, up to my face view. You see how it highlights? And when I let go, you can see it's going to let me pick. And I told you all controllers have this outlet called view, which is the top level view. We'll talk about it on Thursday. But I want to hook this one up to face view. Okay? So I could even run my program right now. I've got everything hooked up. My model, my view controller, they're all hooked up. They're ready to go. When I run, of course, it's going to be blank, because I haven't put any code to draw anything or do anything, but at least these things are hooked up. So that's a good start. All right, so let's start doing some code. Let's start with our draw rect. Let's make our face view draw that face. Okay, so I'm going to close some things here, make this bigger space for us here. I'm going to put some things here to keep this in the middle. So what we're going to do is implement draw rect. So I'm going to take it out of the comment. It says drawing code here. One of the things we almost always do at the beginning of our draw rect, so I'm going to do it, is we get that context. Remember that I told you that we have to get the current drawing context. So we call this method UI graphics get current context. And so now we have the context to draw. We need the context to call any of the core graphics drawing code methods. But let me put some comments here what I'm going to do. I'm going to draw the face. That's a big circle. Then I'm going to draw the eyes. That's 2 circles. Then no nose. Okay, we're not going to have a nose on our face. And then we're going to draw the mouth. Okay, so it's sometimes good when you're writing a method like this to just put a few comments of what you're going to do, because sometimes you'll get into it and you're like, what was I going to do? How was I going to do that again? So here I'm just going to do that. This also helps me realize, hey, look, I got 3 circles I'm going to draw here. I probably could use a little subroutine that draws a circle. So let's do that first. Oops. So I'm going to call it draw circle at point, let's say, CG point. Hopefully, as you watch these demos and you see the code that's in iOS, you're starting to get a feel for the naming conventions, how we name things. And one of the things in naming methods is we really try to have the keyword, like draw circle at point, specify what that argument is. It's a point, right? With radius. So this argument better be a radius. So let's say float radius. In context. Now I could actually use this context and have this method only work in this context, but just to show you how to do this, I'm going to pass the context in to this method. Now I told you that when you call a subroutine, you want to do this thing where you push the context before you go modify it. And then at the end, we're going to pop it back. Okay? And we're going to do whatever we want inside here, changing the line color or anything we want, and it won't break our context that we're calling from. Question?
How would you use the other context if you didn't pass it?
I could call this method inside there, too. Okay. Now, you want to be careful calling this method inside a different method. The question was, how could I get this in here if I didn't pass it along? And the answer is, I could put this line of code up in here as well. But you'd want to be very careful that this method is only called from drawRect, right? Because that's the only time that this is valid. Okay, so what are we going to do inside here to draw a circle? I'm going to do some CG graphics calls here. Whoops. So let's start with CG context. Begin path, showed you that. Pass the context, so we're starting a path. I'm going to draw a circle here. Let's do CG context add arc. I have a little code snippet to help me type that faster, but basically I'm just passing the context, the point, which is the center of the circle, the radius, the angle I want to start at and the angle I want to end at, 0 to 2 pi, it's in radians. And then yes is whether I want to go clockwise or counterclockwise. I'm going to go clockwise, doesn't matter in this case since I'm going all the way around. And then I'm going to say context stroke path. I'm just going to stroke the path. Now notice I'm not setting any line fill or line width. So whenever I draw circles here, I'm going to have to set those in whoever calls it, drawRect in this case. Okay, so now we have this circle thing, we can draw the face, the outer circle of the face. So what's that going to look like? Let's start by getting the midpoint of the face, because obviously the circle needs the midpoint. So that is just, oops, sorry, CG point, midpoint. And the midpoint of a view is basically best calculated by just saying self.bounds.origin.y, or .x rather, plus self.bounds.size.width divided by 2. So I'm just finding my center. Now I'm not using the method center in my view, because center is my center in my superviews coordinate system. And then midpoint at y equals self.bounds.origin.y plus self.bounds.size.height divided by 2. So now I've got the midpoint. And then the question is, how big am I going to make my face? So I'm going to make it like 90% of the width of the shortest of my sides, either the height or the width. So I got to find the shortest. So let's do a float here. Size equals self.bounds.size.width divided by 2. Let's assume it's our width. But if our height is less than our width, then we want to use the height, right? Now, some people, you might be a little concerned, like, oh, we keep calling all these dot things. You know, we're calling all these getters. Again, the amount of overhead to call these getters compared to the drawing we're about to do, completely negligible, right? And we could have a local variable, get the self.bounds, put it in a local CG rec, save ourselves some getters, but you know, really not necessary. And then I'm also going to, again, make my size kind of smaller. I don't want to be right out to the edges. That's not very nice. So I'm going to have a little, define a little thing here, default scale, which I'll say 90%. Okay, so my face is going to go 90% out of the way to the shortest of my size. All right, so now I got everything I need to draw this circle. So I'm just going to, well, actually, let's go ahead and set our line width and line color and that kind of thing. We do that with CG context set line width, for example. Context, let's set it to 5.0 or something like that. That's in points. And then how about setting the color, UI color, blue color, for example. Set stroke. I'm not going to fill the face. I'm just going to stroke the outer part of it. And then I'm going to call self draw circle. So I'm going to call this thing I just defined up there midpoint with radius size. And the context is, whoops, is our context. Okay? So let's see if that works. Right? Voila. Okay, so we got our little circle. It's blue. It looks like it's 90% of the width, which is the shorter of the two things. Notice that if I rotate my thing, nothing happens right now. Okay, it doesn't redraw, it doesn't get stretched, it doesn't do anything else. When we go back later, we're going to go into our controller and support auto rotation. You're going to see that it's going to get stretched. It's going to become an oval, okay, because the default is to stretch the bits. Okay, so drawing the eyes. So to kind of save some time here, I've got a code snippet for this. This is what I'm doing, though. I just have some constants for how far the eyes are away from the middle and how high up, and then the radius of the eyes. And this is in percent of the size of my thing, because I want all these things to be, you know, relative size to each other. Then I just get the eye point by moving up to the left eye. I draw the left eye, then I move over to the right eye and draw the right eye. All right, so let's see what that looks like. All right, so that's working. Okay, so we got a face, we got some eyes, looking good. And now the mouth. The mouth is a little more complicated. We got no nose, so there's no nose. Let's draw the mouth. So the mouth, what I'm going to do is I'm going to draw it with Bezier curves. I don't know if you all know what a Bezier curve is, but it's basically you draw a line between 2 points, and then you have control points where the Bezier curve is basically passing by those control points in a well-defined way. So let's go ahead and do that. So I have this thing mouth. So here's my mouth. I'm going to have a starting point with the mouth. I did the same thing as with the eye. I move over a certain amount and down a certain amount from the middle. And then my smile is basically how big my curve is going to curve for a smile or a frown. So I get the start, which is going to be the left part of my mouth, and I get the end, which is the right side, by adding twice the horizontal mouth size. And then I got these two control points, which are just kind of be slightly below the two corners or slightly above, depending on whether I'm doing frown or smile. And if they're anywhere in between, then the smile will move up and down. Then I have this thing smile, which is going to move those control points up and down. And so 0 means it's going to leave them in the middle. Okay? And if I do smile up to 1.0, then that means the control points are going to move, it looks like, down, right? Because the control points here get added. So it's moved down. So 1.0 would be a full smile, and minus 1.0 would be a full frown. Okay? And I don't want my smile to be anything greater than 1.0 to minus 1.0, or it's going to start being gigantic smile, frown, go off the edge. So I'm going to have to be careful to enforce that later. So now I have these control points. How does the code for a Bezier curve work? It looks like this. So context, begin path, context. Okay, we're always going to start a path here, and then we're going to stroke it. So context, move to the starting point, which is going to be the mouth start and X and Y. Then I'm going to do the arc. Okay, so it's context, add arc. Okay, again, I had a little snippet there to help this a little faster. So the context, we got the point here. So this is going to, oh, this is wrong. That's add arc. Sorry. I want CG context add curve. Okay. So curve is the thing that takes the control points. So you can see that I got a starting point here where I've moved to. Then I've got my two control points. And then I've got the end. Maybe someone could grab that door, because it's making a lot of noise there. So I draw the curve to the point, and then that's it. I just need to stroke it. So let's CG context stroke, path, context. All right, and that's it. So that's how we draw the mouth. So let's go take a look at that. All right, so that's looking good. So we got a mouth. The smile is 0. If I go back here, let's set the smile to 1.0. See what happens there. Okay, it's working. Okay, so that's good. So we're happy, just like this thing's happy, we're happy too. Okay, but now what's next? Let's do the auto rotation thing. Okay, let's go back to our controller. So I'm going to bring up my navigator, go back to my controller, and I'm going to support rotation to any orientation. So I'm going to go back here, and all I need to do is implement this method, should auto-rotate the interface orientation. I'm just going to return yes. Oops, yes. Okay, so that's going to allow my view, top-level view of my controller, to change to any orientation. Let's see what happens when we do that. Okay, so here it is. Now I'm going to rotate. By the way you do that is up here in the simulator, rotate left. Okay, so now you can see the problem, where it's taken the bits that I drew before and just stretched them out. It didn't call my draw rect and let me draw it again, okay, round. So we need to fix that. And the way we're going to do that is in our view. We're going to go up here and just set our content mode, self.content mode, to be UI view content mode redraw. Okay, now this won't work. If I were to run again, this won't work because init with frame is not called when our face view comes out of a storyboard like this. All right, so what we want to do instead is self setup, move this up to a setup method, that, and then in awake from nib, self setup. So now our content mode will get set to redraw, which means that when our bounds change, because someone changed our frame, we'll call a draw rect, whether it's coming out of a view or whether someone does alloc init with frame. So let's go see if that works. So here we are. We rotate and see it redrew. Called our draw rect again, and our draw rect was smart in that it looks for the shorter of the two sides and then draws it that way. All right, so the next thing we're going to do is we're going to add a pinch gesture to change the size of this face, to zoom in and out on our face. Now, the zoomedness in on our face has nothing to do with the smiliness of our face, okay? So the handler for that does not need to be in our controller. In fact, probably doesn't want to be in our controller, because other controllers might want to use this face view, and they might want to pinch also. So we wouldn't want that code in our controller. We want it in the view. So how are we going to do that? Well, to make things easy on myself, I'm actually going to add another property to my face view called scale. Okay? So I'm going to make setting the scale of my face view a public property. Anybody who wants can set my scale. Okay? And the scale is just going to be how zoomed in I am on the face. So let's go back over here and make this work. Let's put our synthesize in. Sorry, synthesize. Scale equals underbar scale. I'm going to do a couple of interesting things in the getter and the setter. Okay? So in the getter, I'm going to check and see if scale is 0. Because 0 scale makes no sense. My face would not be drawn at all if it was 0 scale, or at least I'm deciding it makes no sense. So if it is 0 scale, what am I going to do? I'm going to return this default scale, the 90% thing. All right, so let's go up here, move this up a bit, return default scale. Oops, default scale. Otherwise, I'll just return the scale. Else, return scale. Okay? And I'm going to do something in the setter, too, for scale. Oops, got to return there. That's a CG float. So I'm going to do another thing here in the setter of scale, and this is something very commonly done in the setters of properties of a view, which is I'm going to set my scale, and then I'm going to do self set needs display. Oops. Do you see why I'm doing that? If somebody sets my scale, makes my 50% scale or something like that, I got to redraw. Okay? So I want that to be automatic and instantaneous. Really, to be efficient here, I might also do something like this. If scale does not equal underbar scale. Now, I haven't been doing that in setters, in other setters, but set needs display ain't cheap. Okay, set needs display is going to cause this thing to be redrawn. Okay, now we are talking about something that's going to take a little bit of CPU resources. Okay, so I don't want to do that without a little bit of thought. So here it is worth putting in a little extra code to stop doing that. Make sense? See? All right, so that's our scale. So now how do we implement a handler? So I'm going to call my pinch handler pinch, and it's going to take a pinch gesture recognizer. Now I have not added my gesture recognizer yet. Gesture. And that's something here to help me type this a little faster. So here's, I'm checking to see if the gesture is in the state changed or the state ended. Okay? So as long as the pinch is happening or at the last point of the pinch before it ends, I'm going to track it. And all I'm going to say is self.scale times equals the gesture scale. But if I'm going to do that, I can't have a cumulative scale going on here. I need incremental scale from the last time this was called. So I'm going to say gesture.scale. Oops, there's the problem with the code things. Sorry. Gesture.scale equals 1. All right, so I'm going to reset the scale of the gesture to 1 all the time, so that as it's getting bigger or smaller, it's always telling me compared to the last position of it. So this is a really cool way, if you have a stateless recognizer handler, to do this. Now, if I run, this is not going to work. Okay, pinching is not going to work, and hopefully you understand why. The way you test pinching, by the way, if you hold down the Option key, then you'll get these little 2 dots, and then if you mouse down, it'll be pinching. Okay, you can only pinch about the middle. So limited simulator testing of this thing. On a device, obviously, you just pinch. So it's not working.
If you hold shift, you can shift the 2 dots up.
Exactly, yeah. You can also do shift. I want to get up higher, you see. And then go like this, move down here. So you can kind of move it around. But it's not pinching. And why is it not pinching? Because all we've done here is implement the handler. But we never added a recognizer to our view to actually recognize the pinch and call our handler. So that's what we need to do. And that we're going to do in the controller. So we're going to have our controller add that gesture recognizer. It's not going to do the implementation. It's going to let the view do the implementation. Now, we're going to make our pinch here public because we want to let anybody who uses our face view know that we implement pinch in case they want to pinch. See why we make that public? Right? So anybody using face view says, oh, look, face view does pinch. Oh, I'm going to add a pinch recognizer. And what would that look like? I'm going to add it in the outlet setter for my face view. Right? So in other words, when the system connects my face view up to my controller, that's a great place to add a recognizer. And I'm just going to say self.faceView, add gesture recognizer, UI pinch gesture recognizer, ALEC. And then the init is init with target. Now the target is the object that's going to handle this gesture when it happens, which is self.faceView. Everyone understand that? The view is going to handle it. And the action is @selector pinch. Okay, got too many parentheses there. All right. Everyone understand this line of code? See if I can make it all in one line so you can see it better. Right? I'm just going to add a gesture recognizer to the face view, and the face view itself is going to handle it using its pinch method. All right, so let's see if this works. All right, so here we go. Holding down Option. Still not working. And so what's wrong here? Are we not getting the pinch? The answer is we are getting the pinch, but we're not doing anything with it. Our face view sets our scale, but we never use our scale. Right? Does that make sense? In other words, we never use self.scale anywhere. So we need to use self.scale, and luckily, I created a nice place to put it, which is the place we do the default scale. Instead, I'm going to get our property scale. Okay? So that's going to set the scale that we're going to use. So let's try that. All right, so here we go. Option key, and now it works. Okay? And it should work in this mode just as well. Okay? So that's good. All right, so we're out of time here. So next time, what I'm going to do at the beginning of the next lecture is we're going to do 2 things. One, I'm going to add a delegate to my face view that allows the face view to get its data, which is the smiliness of the face, from someone else. Then the controller is going to set itself as the delegate and provide the smiliness after doing some translation using the model. And then the last thing we're going to do is I'm going to add another gesture, which is a pan up and down gesture, to control the happiness. Right? And that recognizer is going to be in the controller because it's going to modify the model directly. Everyone got that? Okay, back, hold on one second. Back to here. Coming up next time, I'll finish this demo, then we're going to talk about view controllers in detail. We talked about views on Thursday, and today we're talking about view controllers on Thursday, including the life cycle, creating controllers of controllers. That's the complicated MVC thing I showed, where MVCs use other MVCs as their view. We'll talk more about storyboarding. We've really only just barely scratched the surface there. We'll make a universal application. Hopefully we'll have time for that, to make one on the iPad and iPhone. And on Friday, the section, another, I keep saying they're brief, but sometimes they end up not so brief, but Friday is about getting your project running on the device. Okay, so that's getting the right authentication and a provisioning profile and all that stuff so that you can run your stuff on the device. All right, guys, if you have any questions, I'm here.
For more, please visit us at Stanford.